Right now, as you're reading this, there are roughly 10,000 trillion oxygen molecules distributed through the air around you, and you're not thinking about a single one of them. You've never had to. Your lungs pull them in, your blood carries them off, and your cells burn them for energy in a process so automatic you'd forget it was even happening if you didn't occasionally get out of breath running for a bus. So here's the question. What if, for exactly 5 seconds, all of that oxygen simply vanished? Not slowly depleted, not gradually thinned out, just gone, everywhere on Earth, all at once, for 5 full seconds, before snapping back like nothing happened. The answer is stranger, more violent, and more instantly catastrophic than you'd expect, and it has almost nothing to do with people simply running out of breath. Let's get the obvious part out of the way first, because it's actually the least of your problems. 5 seconds isn't long enough for you to suffocate. Your blood is already carrying oxygen through your body. Your brain has a small buffer, and losing 5 seconds of new oxygen intake wouldn't kill you outright the way people assume. If oxygen loss were the only thing happening, you'd feel lightheaded for a moment, and that would be it. But oxygen isn't just the thing you breathe. It's structurally, chemically, holding an enormous number of things together and apart that you never think about, and removing it instantly breaks all of those things at the exact same moment. Start with the sky itself. About 21% of our atmosphere is oxygen, and that oxygen has weight. It's part of what gives air its density, its pressure, its physical presence pushing against everything on the planet's surface. Instantly remove a fifth of the atmosphere's mass, and you get a sudden pressure drop everywhere on Earth simultaneously. This isn't a gentle breeze. This is the atmospheric equivalent of yanking a rug out from under the entire planet at once. Massive pressure differentials would trigger hurricane-force winds in every direction as the atmosphere violently tries to redistribute itself. And this would happen everywhere, all at once. No build-up, no warning. Just instant chaos in the sky above every single person on Earth. Now here's the part almost nobody thinks about. Welded and bolted structures. Steel beams and skyscrapers, bridges, any structure held together by welds, are fused through a process that relies on oxidation, chemical bonds formed with oxygen atoms present in the metal itself. Scientists have pointed out that removing atmospheric oxygen for even a moment could interfere with the surface oxide layers holding welded joints together. Some welded structures might not fail instantly, but the chemistry keeping certain bonds stable would be disrupted in ways that could weaken structural integrity right at the moment hurricane-force winds are tearing across the landscape. Bridges, buildings, infrastructure, all of it under simultaneous stress from 2 directions at once. Then there's the ground under your feet, literally. A huge percentage of the rock and soil that makes up the Earth's crust contains oxygen bound up in silicate minerals, quartz, and countless other compounds. This oxygen isn't going anywhere. It's chemically locked into solid rock, not floating around as breathable gas, so the ground itself wouldn't crumble. But the atmospheric oxygen closest to the surface, the stuff mixed into soil, water, and the thin boundary layer where air meets Earth, would vanish, and the chemical processes depending on that interaction would stall out for those 5 seconds across the entire surface of the planet. Now think about fire, because this is where things get almost beautifully ironic. Every flame on Earth, every pilot light, every car engine mid-combustion, every candle, every gas stove, all of it requires oxygen to sustain combustion. Remove the oxygen, and every single flame on the planet would simply go out. Instantly. All at once. For 5 seconds. Earth would have zero fire anywhere on its surface, a planet-wide blackout of every burning thing simultaneously, which honestly sounds almost peaceful compared to everything else happening in those same 5 seconds. But it's not peaceful, because the moment oxygen snaps back into existence, all of that fuel that was mid-combustion, all those engines, stoves, industrial furnaces, would suddenly have oxygen flooding back in around superheated fuel and hot surfaces. That's not a gentle relighting. That's the recipe for explosions. Thousands of them, everywhere, simultaneously, the instant oxygen returns, because you've just recreated the exact conditions needed for combustion to violently restart around material that never stopped being hot. And what about the ocean? Water is roughly 11% hydrogen and 89% oxygen by mass, But that oxygen is chemically bonded within the water molecule itself, not floating freely as gas. So removing atmospheric oxygen wouldn't make the ocean evaporate or disappear. The water molecules stay intact. What would change is the oxygen dissolved in the water, the gas that fish actually breathe through their gills. That dissolved oxygen would vanish right alongside the atmospheric supply. And for those 5 seconds, marine life pulling oxygen from water would find nothing there to pull. Here's an unsettling detail: the ozone layer. It's made of ozone molecules, which are just oxygen atoms bonded together in groups of 3 instead of 2. Remove atmospheric oxygen, and you remove the ozone layer's raw material along with it. For 5 seconds, Earth's ultraviolet shield would have a gap in it. 5 seconds isn't long enough for meaningful radiation damage to reach the surface in any serious way, but it's a genuinely strange thought. For a few seconds, the planet's ancient radiation shield simply wouldn't exist. So let's zoom back out and put the timeline together, because this is where the sequence actually gets terrifying. In the first split second, atmospheric pressure collapses and hurricane-force winds erupt globally. Within that same instant, every flame on Earth extinguishes at once, plunging any fire-lit or combustion-dependent system into sudden failure. Structural bonds in welded and oxidized materials come under invisible chemical stress, while physical stress from wind loading hits buildings and bridges simultaneously. Marine life begins losing access to dissolved oxygen. And then, 5 seconds later, oxygen rushes back into an atmosphere still churning with wind, into engines and pilot lights still burning hot from an interrupted combustion cycle. And the returning oxygen doesn't gently restore normalcy. It ignites everything that was mid-burn into an explosive comeback, all at the same instant, everywhere on the planet. Humans, in the middle of all this, would mostly be fine from the actual breathing part. You'd get lightheaded, maybe disoriented, and completely unaware of the atmospheric violence unfolding around the planet in real time. The danger to people wouldn't come from suffocation. It would come from being inside a building whose structural integrity briefly wavered, or near an engine about to backfire with explosive force, or outside during winds strong enough to move vehicles, all triggered by a phenomenon that, from a human biological standpoint, barely registers as dangerous at all. This is genuinely one of the strangest things about thought experiments like this one. The part that sounds most dangerous to us, running out of air, turns out to be almost irrelevant. The actual devastation comes from all the invisible chemistry and physics oxygen quietly holds together that has nothing to do with breathing whatsoever. We think of oxygen as something we consume. In reality, it's something the entire physical structure of the modern world is built on top of, silently, permanently, everywhere, all the time. So the next time you take a breath without thinking about it, which is every single breath you've ever taken, remember that oxygen isn't just fuel for your lungs. It's the quiet, invisible glue holding fire, metal, wind, and ocean together in a fragile balance that would take exactly 5 seconds to reveal just how much is actually depending on something you've never once had to think about.